Our essential questions for this lesson are: how do stoichiometric ratios relate reactants and products in a chemical reaction? How are stoichiometric ratios used to predict the amounts of reactants and/or products? And how can dimensional analysis be used to express stoichiometric ratios? By the end of this video, you should be able to use stoichiometric ratios to convert between mass of one substance and volume of another. Here's the stoichiometric roadmap again. In this lesson, we're going to be going from mass of one substance to volume of another. So we're going to follow along this path. So again, it is going to be 3 steps. To go from mass to moles, I'm going to use the molar mass. Then moles of one thing to moles of another, you're going to use the coefficients from the balanced chemical equation. And then to get from moles to volume, you need to use 22.4. The question we're looking at is: determine the volume of nitrogen gas needed to produce 92 grams of nitrogen dioxide in the following reaction. So again, we're only looking at 2 things. We're looking for how much nitrogen dioxide I can form, and we're looking for how much nitrogen gas that needs. That means I can completely ignore the oxygen as part of this reaction. What we're given is that we need to produce 92.0 grams of NO2. Because this is not in moles, my first step is get to moles. So my first set of parentheses, I'm going to be using the molar mass of nitrogen dioxide. Since I have grams of nitrogen dioxide on the top, the grams must go on the bottom. The molar mass of nitrogen dioxide is 46.0055 grams, and that is the mass of 1 mole. Now, the grams of NO2 cancel out, and here I would have moles of NO2, but I'm actually looking for nitrogen gas. So my next set of parentheses is going to take me from moles of NO2 to moles of N2. Because moles of NO2 is on the top, I need to put units of moles of NO2 on the bottom, and that's going to go with its coefficient. And I'm looking for moles of N2, so that goes on the top with its coefficient. The moles of NO2 unit will cancel out, and I have moles of N2. However, I'm looking for volume. So you need to remember that the volume for any gas, if I have 1 mole, is 22.4 liters. So since I have moles of N2 on the top, moles of N2 goes on the bottom, and the volume for 1 mole of any gas is 22.4 liters. So the moles of N2 will cancel out, and when I plug this into my calculator, I will get the final answer. So 92 times 1 divided by 46.0055 times 1 divided by 2 times 22.4 divided by 1 gives me 22.4 liters. And that is to 3 significant figures. So remember, the first step is to get to moles. Then the next step is going to take you from moles of one thing to moles of another, which is always going to use the coefficients of the balanced chemical equation. And the final step is to take you to whatever units you are looking for. The only time you use the coefficients from the chemical equation is when you have moles of one thing to moles of another.